All right, let's do the same thing for secant. So secant is the equivalent of 1 over cosine. So we're going to go through the same routine. It's just from our unit circle. We're using the x coordinates, which are cosine. So we'll just be using those to help us out. But it'll be similar where we take that cosine value and flip it to get the secant value. So at negative pi, we're at -1. I'm just going to throw that 1 underneath to help us visualize. Negative root 2 over 2, 0, root 2 over 2, 1, root 2 over 2, 0, and what did I do? I went too fast. -1, negative root 2 over 2, 0, root 2 over 2, 1, root 2 over 2, 0. Nope, I'm good. Sorry, got thrown off there. 2 over 2, -1. Okay. So there are values, and then for secant, we're just going to flip those. So -1 flipped is still just -1. This will be a negative root 2. This will be undefined since 0 will be in the denominator. Positive root 2, positive 1, positive root 2. This will be undefined. Negative root 2, -1. All right, so let's see where these asymptotes are landing. So negative pi over 2 and at positive pi over 2. So kind of like with tangent, we're seeing this window around the y-axis, kind of centered, and then we'll just have these asymptotes every 4 units. All right, so plotting these points. At negative pi, we're at -1. At 3 pi over 4, we're at -1.4. And then I can just go ahead and assume that one's there. We're seeing that piece. Here we're at a positive value, so positive 1.4, positive 1, positive 1.4. And over here, negative. So we're seeing a repeat. And then we would be up at positive. And just going to fill in the end here, also positive. All right, so here's our secant graph. And like I was saying with cosecant, if you're unsure of where the pieces are, if you graph cosine on top of this, what you can do is we would be starting at the top here, and then we cross the x-axis, go to the minimum, cross the x-axis, and at 2 pi we return to that maximum. So you can see how cosine fits in this graph with these values coming through. All right, for the domain, what we can see is x is defined as x cannot be. We're seeing an asymptote at pi over 2. And then we're seeing these increments of pi. So every pi units, we're seeing a repeat of the asymptote. So we're going to do start at pi over 2 and then say we'll see those asymptotes for every increment of pi, where k is an integer. For the range, this is going to be the same as cosecant, where you can have from -infinity up to -1, and including -1, so we'll use a square bracket. And what we're going to do is start at +1 and including +1 and go up to infinity. For symmetry, if we reflect over the y-axis, we have symmetry just there. Same thing over here. So with this is symmetric about the y-axis, which means this is an even function. All right, and our last piece here is the period of the graph. Now again, while the asymptotes are separated by a distance of pi, it's really a distance of 2 pi where we start seeing the repeat of our graph. So our period is 2 pi. So with all of our trigonometric functions, tangent and cotangent are the only ones with a period of pi. All of these others are going to use a period of 2 pi.